Here we are. So here's the quiz now. So let's crank through this. So here's the quiz. This will be a good review. This will be actually a very good review. It'll put together everything we've been seeing in Chapter 9. Let's do this first one. So the average American gets a haircut every 39 days. Every 39 days. Do college students get their haircut more frequently? The data below shows the results of a survey of college students asking them how many days elapse between haircuts. So there's the numbers. That's how many days elapse between their haircuts. We're wondering, does that evidence show something, or what does it show? All right, so you know what we need to do. What's the first step in every hypothesis? You would recognize this on the exam next Wednesday as a hypothesis test, right? Because they're saying 0.05 level of significance. That's always hypothesis test talk, right? So what is the claim? We start with the claim, always. What is being claimed in the words? Oh, is this one a percentage problem or an average problem? Average. Yeah, there's no percentages anywhere. I mean, other than the level of significance, that's always there. But yeah, there's no percentages anywhere. This is an average. So it's a mu, not a p, huh? So we're going to say mu equals or greater, less, not equal, something like that. So what is being said, claimed, tested in the words? What does it say?
More frequency.
Yeah, where is it? I don't see it now. Oh, get their hair cut more frequently. More frequently, right?
Yes.
More frequently than what? Than they should? Than the American average of 39 days. Right? Do college students get their haircut more frequently than the American average of 39 days? So what does that mean? Careful now. Are you feeling sharp here at 8:30 at night on a Wednesday night? Because this is a tricky question. What does that mean? More frequently. More frequently. What does that mean I'm going to put here? Greater than or less than? If you do something more frequently, the gap between it is smaller. Right? Right? If you do something more often, this is how long between haircuts. If they get haircut more frequently, the time between haircuts is smaller, isn't it? You like this? This is tricky, isn't it? Sorry. That makes sense now, right? If you're getting your haircut more frequently, then the time between haircuts is smaller. So even though that was tricky of them, they used the word more, but it actually means lower than 39 as the time between haircuts. That's what they're thinking. They're thinking that college students get their haircut more often than every 39 days, that the time between cuts is less than 39. The average time between haircuts is less than 39. Right? Are we okay with that? You'll never be fooled by that again now, right? More frequently. Less time in between. Okay. I think you've got it. I'll quit beating that horse. So now, let's write the HO and the H1. The HO and the H1. So remember how it's always the same letters and the same numbers. So that part's for sure. Always. No change at all, right? The HO and H1 always exactly the same letters and numbers. Now, which way does the symbol... Well, what's HO always? Always equal, huh? Every time. And then what's the H1 going to be? Same as the claim. Yeah, because one of them has to be the same as the claim, doesn't it? So it's going to be the same as the claim. You can write claim right there. And then we should also write weak and strong evidence. They always go weak first, then strong, don't they? Weak evidence, strong evidence, always. Okay, so now we go to our calculator, and we do, now what are we going to go, there's two things you can go to on your calculator. There's the one prop z test, but this is not that, is it? Because this is not a proportion. It's the other one. What's the other one?
The t-test.
T-test. So whenever we're talking average, so we always go to t-test when we're dealing with mu, when we're dealing with averages instead of percentages. Right? So P leads to the proportion. Percentages, P leads to proportion, one prop z-test. Averages go to the t-test, don't they? So we're going to go to the t-test. Actually, first, what do we have to do? I'm forgetting, huh? What do you got to do with all that data? Put it in L1. Yeah, whenever they give us a list of data, that's nothing new. We always have to put all that data in L1. So let's do that. Here's a better look at the data. Can you put that data in your calculator? Put all that data, put that in L1, right? Good, you got all that in L1? So first put all that in L1, then go to the t-test. And when you go to the t-test, which is number 2, it's just number 2 on the list, right? And then you're going to choose, what are we going to choose? Data or stat? Data, because we have a big list of data, huh? So choose data, hit enter, and it'll ask you mu sub 0, list, frequency. So what do you think mu sub 0 is? What are we going to put here with mu sub 0? What's that little 0 remind you of? Yeah, you go back to the number with the null, huh? Whenever they put a little 0, you go back to the null and just put that number in, 39. And the list, that's always L1. Frequency is always 1, just like with the conference intervals, never going to change. And then they want you to select greater, less, or not equal. Which one is ours? Yeah, it's exactly what is on H1, less. So do that. Choose the less. And then calculate. And I'm getting a z value of, it's a t value, huh? A t value of negative 1.5636. I don't know how many decimals they want you to round to. And a p value of 0.0687. You getting those? Coming out for you? All right. And then maybe that's all they want. I don't know. Okay, yeah. So they want, so we good to there? Is that everybody coming out with that okay? Now, how do we draw a conclusion on this one? Remember, it's all about if the P is low, the null must go. So we've got to check out, is the P low or not low? Well, it's compared to the significance level. What's the significance level? I don't see it. Where did they say it? Up in the beginning, usually somewhere. Oh, there it is. Yeah, 0.05 level of significance. So that's what you're comparing to. I'll bring it down here. This 0.05, bring it down there. And then you're supposed to put in between the P value and the level, a greater than or less than symbol, depending on which way it goes. So which way does this one go? Which number is bigger? Is 0.06 bigger or 0.05 bigger? Yeah, the 0.06, it goes that way. So the P, is the P low or not low? Not low. The P's greater, huh? The P's on the wide side. So remember this saying, in fact, let me put it over here for us. If the P is low, the null must go away. But in our case, the P is not low, right? The P is not low. The P is greater. So the HO does not go away, does it? So the HO does not go away. We keep the HO and we cross out the other one, huh? The null does not go away. And how do you say not go away in statistical talk? Fail, yeah, to reject. We fail to reject the null. It does not go away. We fail to reject it. And that's all they want. That's all they want in the question. Oh, they might ask if there's strong evidence or weak. So which one is it on that one? Is there strong evidence or is there weak? Yeah, because we ended up going with HO, evidence is weak. So we'll say not sufficient evidence. Weak. There was not enough evidence. Not sufficient. Not enough. Evidence was weak. See how I know that? Because we stuck with HO. Whenever you stick with HO, it's because evidence is weak. Whenever you go with H1, it's always strong. No exception. It's always weak, then strong. And we went with HO because we failed to reject it. We kept it. So that's weak evidence. We good there? That makes sense? Okay, so here's question 3. I skipped question 2 because it was pretty much the same thing as question 1. So now on question 3. The average American consumes 8.7 liters of alcohol per year. Does the average college student, we had this problem in the homework, huh? Does the average college student consume more alcohol per year? And then there's some data on a research. Okay, so you know what we need to do? We need to write the claim first off. Or the question. The claim, the question, same kind of thing. So what's being claimed? Is this a percentage problem or an average problem? Average amount of alcohol consumed. It's average. It's an average problem. It's a mu, not a p. So eventually we're going to do t-test, not 1 prop z. Right? It's not a proportion, it's a t. Okay, so what's the claim? It's going to be about mu, the Greek m for mean, the average. They're saying the average is what? Or does the average college student consume more? Is the average greater, huh? Greater than what? Greater than 8.7, greater than what the average American consumes. We good so far? So that first one was a real tricky question with the more frequently less time thing. They won't usually do something so tricky. So the claim is the mu is greater than 8.7. More than 8.7. And now we need to write the HO and the H1. So what's the, can you write the HO and the H1? Remember, it's going to be same letters, same numbers. Those never change. And the HO is always equal, isn't it? No exception. So then what's the H1 going to be? Yeah, somebody's got to match the claim, huh? So he's going to have to match the claim. And we'll put next to him claim, and then remember to write in the strong and weak evidence. Always starts with weak. Always, no exception. Weak evidence, strong evidence. Always. So we good? And so now we go to the calculator. And no data here, huh? So we don't have to put a bunch of data in L1. And we'll just go to our calculator. It's going to be t-test because it's not a proportion, again, is it? The averages always lead to a t-test. But this time, instead of selecting data, because we don't have data, you're going to select stat. And so you're going to have some statistical information, right? So when you select stat, then you have mu 0, x bar, s sub x, and n. Kind of a lot of stuff. So what do you think the mu sub 0 is? What is the 0 always supposed to remind you of? The number by the H0, the null number, the 8.7. Good so far? What's the x bar? That's always average, huh? Whenever we have a bar over something, that always means average. So what's the average? Does it say the average anywhere? 9.8. The average 9.8 liters. The college students that they surveyed had an average alcohol intake of 9.8 liters per year. And S sub x, standard deviation, right there, 3.9. N, that's always the total number, 51 college students. And then the last thing, greater than, less than, or not equal, we just grab whatever H1 says. Greater. It's getting easier. Makes sense? Kind of the same flow every time. Hit enter with all that stuff, and let's see what we get. So I'm going to put in the data myself. And it's a greater. Okay, so I did it all, and I'm getting a T, a test statistic that comes out to be 2.014. That's the T test statistic, 2.014. Y'all getting that? And then the P value right below it, P equals a 0.02 4, 6, 8, 9. I don't know how far they want us to round, but there's a bunch of digits anyway. And now we need to draw a conclusion. That's often the hardest part, is drawing a conclusion. But the main statement that helps is if the P is low, the null must go. It's always that. So I'll write that again. If the P is low, the HO must go. Now, how do you know if the P is low or not? Lower than what? Yeah, lower than whatever significance level they say, huh? Yeah, exactly. So the P is 0.024, whatever, and the significance level is 0.05. Right, so you see how I just always set those side by side, the P and then the significance level. They call it alpha sometimes, whatever they want to call it. P and significance level. And then you just put in the symbol, which one's bigger? So this, it might help if you put another 0. That way they both have the same number of digits. So yeah, the 05 is bigger, huh? The wide side, right? The bigger one gets the wide side of the symbol. The wide side is towards the 05. It's the bigger one. So then is our P low or not low? The P is less. The P is low, huh? The P is less. The P is getting the narrow side. So that means he's less, huh? The P is low. P is low. So our P is low. So the null must go. Bye-bye, null. You're out of there. So that is reject the null. Right? Or I should say our P is low. I should say that. P is indeed low. So HO must indeed go away. And go away means reject, right? Reject the null. So we reject the null. That means we keep H1, don't we? We reject the null, we keep the H1. Is there strong evidence or weak here? Yeah, whenever you're doing H1, it's always strong. So that is sufficient, strong. There's enough evidence. There's strong evidence in this situation. Looks like there's strong evidence that the college students are drinking more on average, right? That's our conclusion. Greater. Strong evidence based on this sample. In other words, what we're saying when we say strong evidence is we're saying there's a really low chance that could have been luck. I mean, it could have, right? You could have grabbed 51 students and it just happened to be a lucky group. They were just big drinkers and that's not really the average college student. But there's not much chance of that. The chance that you get lucky like that is only 0.02. There's only a 2% chance that you got lucky like that. It's more likely that that's really the truth, right? Just like when I did the coin flip thing, the chance got really low. We didn't believe it was luck anymore. We believe the college students are really causing that. That's our conclusion there. Is that good? Is that making sense? Can we squeeze in? All right, question number 6. Here we go. Question number 6. So only 41% of registered voters voted in the last election. Will voter participation be even lower for the upcoming election? Of the 422 randomly selected registered voters, 150 of them will vote. What can be concluded with 0.05 low? Okay, so you know the first step, any hypothesis test. So we got to be clear what the claim is. Is this one an average problem or a percentage problem? This is percentage, huh? We're talking about what percent. You see a lot of percentage, 41% and that kind of thing. So this is a percentage problem. Those are the only two kinds we have, average or percentage. So this is going to be something about P, not mu, right? It's a proportion, they call it, or a percentage problem. Okay. So what are they saying about the percentage? They're saying, or what's the question, the claim, the question, will voter participation be even lower? So you're almost afraid to say these now after that super tricky one? It's just what you'd think. Lower is what? Just less, huh? It's nothing. Just that one was super tricky. All the rest are normal. So we're saying lower. That's what they're wondering. Will it be lower? Lower than what? Than the 0.41, huh? Than what it was in the last election, the 0.41. Right? Last time it was 41. This time maybe it'll be even lower. That's the claim. That's the question. Okay. HO, H1. What do we always do with those? Same letters, same numbers. So it's going to be P and P, same letter. 0.41, same number. HO is always equals. So which way is H1 going to go? It's got to match the claim. One of them has to be the claim, right? So there's the claim. And now let's write weak and strong evidence. The first one is always weak evidence every time. The second one, we only go with H1 if evidence is strong. All right, to the calculator we go. So when we go to the calculator, what kind of test are we going to do this time? The one prop Z test, because the hypothesis test, yeah. Right, not the t-test, because that's only for averages. So those are the only two kinds we use for a hypothesis. Either one prop Z for proportions or t-test for averages. And you have all that on your exam 3 notes. Okay, so when you go to one prop Z, which is number 5, you get P0 X in. So what is P0?
0.41.
Yep, it's always the number next to H0. They're just reminding you of that. So 0.41. What's the X on this one? Yeah, it's that 158. Yeah, it's that 158. And what's the N? 422 total people. Yeah. And then, right, it's getting more comfortable. And then which way do we go with the greater than, less than, not equal? Always the same as H1. No exceptions. Always the same. So less than, just like H1. Hit the enter button. And what do we get? We get a test statistic, Z, which is equal to negative 1.4866. I don't know how many places they want you to round. And then the p-value, getting a p-value equal to 0.06855, whatever, blah, 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 blah. However many they want you to do there. Don't worry about that other P down below it. Just grab the top P. It's always the top one. And now let's try to draw a conclusion. We've got to go with that statement. If the P is low, the null must go. So let's bring the P value over here. The P is 0.068, whatever. And what's the alpha level, the significance level? Oh, there it is, 0.05. It's usually 0.05. Not always. They can make it 0.01 or 0.10, but it's usually 0.05. Bring that down. The significance level is 0.05. Okay, so the question is RP, which of those is greater? 06 or 05?
06.
Yeah, the 06 is greater. So is the P low?
No.
No, RP is greater. He's not low. He's on the wide side, not the narrow side. So that means if the P is not low, the null does not go away, huh? So the null is not going to go away. Meaning we're going to keep the null and the other guy's going to go away. The H1's going to go away. So how do they say that in statistical talk? Failed to reject. It didn't go away. We fail to reject the null, don't we? Right? The P was not low, so the null did not go away. We did not reject the null. We failed to reject. And is evidence strong or weak? Yeah, it's always weak when you're doing the null, huh? It's always weak. So weak evidence. And how do we say weak evidence? Not sufficient. There just wasn't enough evidence. Not sufficient evidence to draw our conclusion.